Alright folks, welcome back to another Math Note video. This is Mr. Jewell, and we're going to be looking at section 1.1.3 Math Notes today on graphs with asymptotes. As you may or may not remember, asymptotes are just invisible lines on the graph that your graph approaches. So we have a horizontal asymptote here. This blue line is getting closer and closer to that horizontal asymptote, but it never actually gets there. That's part of what it means to be an asymptote. Is this your graph is going to get closer and closer to it, but never quite get there. You can have a vertical asymptote. That's this dotted line right here, and the graph once again is approaching it, but never quite getting there. Or you can have an oblique asymptote, which just means it's at an angle, has some equation other than a horizontal or vertical line. Remember that because we're talking about horizontal and vertical lines, if we wanted to find the equation of this dotted line, since this is horizontal, the equation is just going to be y equals some number, whatever line or whatever part of the y-axis that horizontal line crosses. For a vertical asymptote, it's going to be x equals some number. And for an oblique asymptote, if it's a line, then it's going to follow the y equals mx plus b format, because it's going to have the equation of a line. So let's take a look here as we go through these math notes. So this says a mathematically clear and complete definition of an asymptote requires some ideas from calculus, but some examples of graphs with asymptotes should help you recognize when they occur. In the following example, the dotted lines are the asymptotes and the equations of the asymptotes are given. In the lower two graphs, the x-axis y equals 0 is also an asymptote. So let's take a look at these. Here we have two curves. We're not given the equation of those curves, but we can see that there are two asymptotes. This curve is getting closer and closer to this vertical line here, which has the equation of x equals 2. And it refers to this vertical line. And then we also have the horizontal line here, which is another asymptote. Let's see if I can draw it straight here. Which has the equation y equals 3, because it crosses at 3. That's not marked. This would be 3, and this would be 2 on the x. Here we have another graph. It looks like this. You get this with probability distribution sometimes. We have another horizontal line, y equals 5. That means that this line right here crosses our y-axis at 5. Down here we have a curved asymptote. It's actually the equation y equals x squared, which is the parent function or the mother function for parabolas. And these other two curves are going to approach it. They're going to get close but never actually reach it there. And there's another, so that's this guy right here, is our y equals x squared. And we have another asymptote that's actually right here. Again, let me see if I can draw that a little more straight. That goes through x equals 0. This is the line y equals x, and then there's another x equals 0 asymptote. So you can see in those examples, asymptotes can be diagonal lines or even curves. However, in this course, they're always going to be horizontal and vertical lines, which keep things a little bit easier. Let's take a look at, I'll let you read through the rest of that on your own. To finish off the video here, I want you to give me the equation of the two asymptotes that are on each of those graphs. So the two asymptotes that are on each of those graphs. You might have to make a little bit of an assumption on this one here. So, tell me why you chose that, and we'll go from there. And have a good night.